Welcome to the tablespace seminar. In this seminar, we will cover most of the tablespace commands which are used by DBAs on a daily basis. The first slide here shows the various data dictionary objects which are normally used to get the information about your table spaces. And remember, we're talking about a multi-user system and complex environments with high precision constraints, and following all these constraints, we have to make sure that the response time is optimal. And to achieve those OFA goals, the response time goals, and having a proper space management of my objects, of my projects, of my data, what we have to do is make sure that the table spaces are also placed in an optimized fashion on a given RAID system. So what derives how many table spaces we need, what derives how many data files must be present in a given table space or are required in a given table space, is a simple fact. Better throughput, better response time, better space management following the OFA structure. So if you remember these 4 points before you start creating on any object, you are going to be in a great shape. Now let me put a case in front of you. Imagine, let us talk about space management. Imagine you are part of the data warehouse project where there are 20 different data sources. One of them can be SAP system, one can be PeopleSoft system, another can be Oracle 11i ERP system, okay, and various custom homegrown OLTP systems. And you are building a database, a data mart or a data warehouse, and feeding on those external systems, and you are denormalizing and building a star schema or a snowflake schema design in the data warehouse. The transition systems may be running for 20 years, 15 years, 10 years, and you're dumping all your data into one single huge database. So what you can do, you may only be having say 50 tables or 100 tables which are like your fact tables, and you may have maybe 100 more lookup tables which are attached to your fact tables. So they are fact tables which are like denormalized tables, and they are lookup tables. So you will basically in a data warehouse join at the most 2 or 3 tables. You don't go beyond joining. When I say there should be master and child relationship, if you go master child relationship, that means you're going to a snowflake design, and that means you are possibly not following the design principles, or you may have to denormalize further your data. But anyways, so these denormalized tables have the tendency to be like 10 million rows, 20 million rows, 50 million rows, 100 million rows. And as a DBA, you are assigned to create some database and the table spaces and the objects. So nobody is going to tell you to create 1 table space or 10 table spaces, right? You have to come with a design based on the 4 things we talked about. So the first thing is space management. So now either I can dump the 1 terabyte data into one big table space and one data file, assuming that the operating system has no limitation on the data file size, okay, or I can have 1 table space and 100 different data files which are part of a table space, and they can all have your tables spread across, because if you remember, in the logical structure and the physical structure class, we discussed when you create an object like table, the extents can be randomly assigned to any table space based on what Oracle decides to do internally. So now the problem in the space management side is if we end up having data files which are of 10 gig and 5 gig and 15 gig and 10 gigs and again, and you want to move them around, what is going to happen? You need to have a bigger free space somewhere else in some different mount point, and that may be a big management issue. So what you may have to do at that point, if that is the situation, you may have to export the user, recreate all the table spaces, and have more smaller manageable data files. Okay, so there's no fast formula, but you should think in terms of management. And also, let us say you have different RAID sets under different controllers. You may want to move you have like say 20 hot tables. They are always hitting the 20 tables, and you want to have a physical isolation of 10 tables under each controller on a different RAID set. That is also possible. So there's so much things you can do if you manage your object size properly, if you manage your data files and the table space contents properly. So that part also takes care of your response time and throughput and your I/O distribution, because you have better control how you can place your data files and the objects inside the data files like tables and indexes, and how they can be distributed in a different RAID subsystems and different RAID sets under different stripe width and under different controllers. So because not only you do the object management at the table space and the data file level, but eventually that has to go to a well-defined and well-managed and I/O system also. So as you can see, all things are fitting together: the RAID, the table space, the object placements, and all these things. So that is now you can also relate all these things I'm saying to OFA. You have to distribute your I/O so there's no bottleneck for better response time and for better space management. So having said all that, I think this should be enough to let you think about how you should design and how many table spaces and how many data files there should be. So if I have another example might be if you want to isolate your different projects. Let us say you have one big database and you have 10 different projects, and one is say order entry system for the web users, and there's one accounts payable system, homegrown possibly, or some Oracle ERP system in the same database, and that is also using forms and using web-based interface. There can also be, say, you have some audio video system you have built to stream your data from the CLOB, BLOB columns from a table, right? So there are different characteristics of these projects. There are different requirements of the storage. There are different requirements from the stored objects in terms of what is stored there, what can be retrieved, how you want to retrieve data, and how the data is going to grow. One order entry system, if you are, let us say you're hitting 1000 orders per hour, you may see that order entry system objects are growing at a rapid pace compared to other objects in different projects, but they're all in the same database. So I will, as a DBA, create a different user for every project, and under each user I will have different table spaces, and I may have more data files or more table spaces depending on how we are going to manage my objects, how they will grow. And Oracle has, as we will discuss now, there are 3 different types of table spaces: dictionary managed, locally managed. There are 2 locally managed table spaces. One locally managed table space is called is basically locally managed and the extent management is local, but we also can specify the uniform size of that extent. We will see that in the commands. The other one is okay, locally managed, but it is auto allocate. So Oracle is managing your extents for you. And there is dictionary managed table space, where Oracle does all the internal calculations for you to allocate your extents when you create an object in that table space. So if you want, and also in we will see when we do the test, I have designed 20 test cases for you on the table spaces. You will see different types of table spaces, and when we create the objects in different types of table spaces, how they behave. And why do we need a table space? Because without a table space, the lower level logical objects like tables, indexes, users cannot exist. You have to have a user, you need to have a table or index. They all must reside in some table space. Okay? Your PL/SQL code, you create SQLs, your PL/SQL procedures, your functions. Where do they reside? System table space. Unless you modify your SQL.bsq script, which is part of your catalog script, you cannot control that my PL/SQL procedures will go in a specific table space. All PL/SQL procedures, all PL/SQL code will by default, it's not easy to change, will go in a system table space. Okay. Anyway, so this first slide is demonstrating us that these are my various data dictionary objects to get the information. And the first one is DBA underscore table spaces, and there's TS dollar and user underscore table spaces, and these will tell you the list of table spaces and whatnot, and all the default are they and the status, and if they are auto extendable and things of that nature. Table space quotas will tell you that what user has what quota on what table space. Data files, the DBA data files, and VDOR data file, VDOR data file copy, VDOR data file header. These are all the tables used to provide us. They are used to store all the information about the data file. For example, the $$ data file header stores the data file header information. As I said, every data file has the first block, which is your header information, which tells about the data file itself. The DBA underscore data underscore files list the relationship between the table spaces and the corresponding data files. $$ data file is used for demonstrating the location of your data files, where they are located, the names. DBA underscore data underscore files also holds the size of your files along with the relationship between table spaces and the data file names. DBA underscore free underscore space lists the how much space is free in each table space. DBA segments will tell you how many different types of segments we have. I think we already covered this in the logical structure class. $$ segment statistics is new in 10G, and that will list you all the statistics on the segments. We will cover that when we go to 10G. DBA extents will tell you list of all the extents. This is the lowest level. Again, remember, best. The top level structure is table space. Table space has one or more data files, and data files are broken down into logical structures. The top level of that structure is called segment. The segment is big, like table segment, index segment, LOB segment, table partition segment, index partition segment, right? So the next level of your segment breakdown is called extent. What is extent? Extent is group of continuous blocks, not group of random blocks, group of continuous blocks, and that information is stored in DB extents. And DB extents basically forms the relationship between your blocks, extents, segments. This table can get huge. For every extent there will be one row. So if you have 10,000 tables, and 10,000 tables each has say 10, 100 or maybe 200 or 500 extents each. So you have 10,000 times 500 rows in the table at least. Blocks. If you have corruption in the blocks, we can look at this table, V dollar database block corruption, the DBA table space groups, and the next V dollar sys occupants are 10G features. We'll talk there. DBA temp files. There are various kinds of table spaces. Whereas one of them is system table space, then we have data table spaces, we can have index table spaces, we can have rollback table spaces, we can have undo table spaces, we can have something called temporary table spaces. The temporary table spaces are used for sorting, merging, and grouping, and even hashing, storing intermediate hash tables. So temporary segments are used for, as it says, some temporary purpose for a short period of time. Okay, so if you have temporary table spaces, they are not normal table spaces, so the structure is different. Oracle has given a different data dictionary object called dba_temp_files to demonstrate the statistics, the information about the temporary table spaces. dba_rollback_segs, it gives you a list of all the rollback segments. In a system, rollback segments are required to give you the read consistency on your selects. This is kind of critical. When you're doing undos are used, or redos are not redo logs, undo or rollback segments are used to go backwards. You want to go backward in time. What I'm saying here, let us say, again, we have multi-user system. Let's say user 1 make a change on a table, and that table is shared between 1000 users. The first user makes a change, but he made a change. Let us say the table has 1000 rows, and he updated. And he wrote a command update blah blah blah, and he updates all the 1000 rows. What happens next? What happens to the other people? All the other people which are sitting and selecting and doing some other operations on the same table. Let us say there are 10 more users and they are doing a select, and I am the one who made a change. I said update the salary to 0 for every 1000 rows we have here. Okay, but I did not commit yet, and unless I commit, the change I made is specific to my session, to my transaction. What is a transaction? Transaction is anything between the last commit or rollback up to the current point. So when you log into SQL Plus, by default you're starting a new transaction. Any statements you make, insert, update, delete, that will be part of your same transaction thread, unless you do a commit or rollback. When you issue a commit or a rollback, all those statements which are part of a single transaction will be either committed in one shot or rollbacked in one shot. And all this information, the transaction ID, the transaction, what transactions went in the transaction set, will be rolled into your where, because I made my changes in the database buffers. From database buffers, where will it go? It will go to redo buffers. From there, on commit or rollback, will go to your online redo files. On checkpoint, the database writer will make sure all the buffers which you have changed, also called dirty buffers, are written to your database files. On commit, DB writer doesn't write, only the log writer writes, right? So what happened here? When you're making a change, I also said something in the transaction set that the previous copy, the original copy, anything you are changing, Oracle must save the original copy of the change. So that copy goes to your specific spot in the database buffer cache, and that part is called a rollback segment. Oracle uses the rollback segment structures, and those rollback segment blocks are part of your database buffer blocks, and those are used to store your previous copy. So I, as a user, made change to 1000 rows. 10 different users are looking at the data, but they're not looking at my data which I've changed, which I made all my salary to 0, because I have not released my transaction. I didn't say commit and make the change public to everybody. I didn't say roll back and say forget what I did. So nothing is changed. So what will happen? Oracle will release the rollback segments which are held, and other people can override that. We'll go in that detail, but you got an idea. So why so what is going to happen to 5 people? I mean by change, what will they get? Will they get 0, or will they get, say the original value was $1,000 each? They will all get 1,000. But in the table, on the table blocks in the database buffer, I made 0. How come they are getting the 1,000 value? Because the values, original values, are stored in your undo segments, undo blocks, also called in ADI rollback blocks, right? So we are going backward in time. The current time is, and the current values are all zeros. For other people, since I haven't committed, they have to get the read consistent view of the data based on when their transaction started. When they started their transitions, when they started their selects, the data was 1000. So they must all see 1000, not 0, unless that zeros are committed and released to the public, right? So for that purpose, we have rollback segments. We will do a test on these entries and things of that nature. In ADI, we had db underscore rollback underscore segs to manage list and do all operations like how many rollback segments we have, the initial extent, next extent, and your wrapping information and optimal information. So everything which goes along with the rollback segment is stored here. The db underscore undo underscore extents is new in 9i and 10g, and in 9i we have something called undo table space. Let me put a comment here. Let us say we have 1000 users. They all doing commit, insert, and they are also doing changes. All their previous copies of the changes have to be stored somewhere in the rollback segments or undo segments. By the rule of thumb, for every 4 transactions, divided it by 4 is optimal number to have your optimal number to basically dictate your number of rollback segments you need. So I have let us say 100 transactions at a given time. So 100 divided by 4, so I should have at least 25 rollback segments. But that is a rule of thumb which we don't follow anymore. It used to be earlier releases. So what has happened here? If let us assume we have 1000 users and 1000 transactions at every given point in time, the rollback segments are shared among all the users. So each transaction, which are say spawned by 10 different users, they may all share the same rollback segment. For better optimization and performance, we recommend having 4 to 5 user transactions per rollback segment, but that doesn't mean that is a limitation. So it gets very complicated to manage if you're running big jobs like asset depreciation and mass addition and your FSG computation. You may require a very huge rollback segment, and then it becomes, shall we have smaller rollback segments, shall we have bigger rollback segments, how many smaller sized rollback segments? When I say smaller size, basically means your initial and next extent are smaller. When I say bigger size, means I have initial and next like big, like maybe 1 MB, maybe like 4 MB, or maybe 20 MB each. So how do we design? In a OLTP system, or it is a hybrid system like Oracle application where it is 60% OLTP and 40% reporting, or maybe 60% reporting and 40% of OLTP. How do we design? How do we keep the size of role by segments? How do we decide? Shall we keep them all small, all big, or one big, or rest of them smaller? So to avoid all this kind of confusion, we had to tune of role by segments a lot, because again, this is again one of those redo kind of things where everybody's going to use it. Redo buffer kind of thing. So it is, role by segments will be used by everybody. That is how Oracle works. So okay, but to avoid these problems, Oracle came with something called undo segments. So what you do, you create something called undo table space, and that undo table space is mentioned in your init.ora file when the database starts, and Oracle internally manages all your undos using this table space. It will dynamically create the rollback segments as it needs. It tries to keep for every transaction one rollback segment, and they are all system named segments. Okay, so this is things. So why I said that, because I will be showing you the commands to create those table spaces, so you need to know that. v.roll set and v.undo sets are some statistics you can get from the table to get an idea about the rollback segments, how they're behaving and the performance and things of that nature, how they're growing, how they're wrapping, and things of that nature. Dictionary management, there are FET dollar tables and UET dollar tables, free extent management and used extent management. So Oracle has to maintain all the extents which are used and unused in these tables. Okay, let us now first try to do some operations on the control file. The control file operations are done using the alter database command. So in this first command, I am showing you that we want to back up the control file. So if you are doing a lot of changes, what does control file have? The location of all your data files, all the SCN numbers. It has the information about all the physical structures, not the logical structure. It doesn't hold anything about tables or indexes or users, but it does have information about number of data files, where they are located, things of that nature. Where are my redo files? How many control files do I have? So we should back up the control file. We should back up the control file to secure my control file. The command to do is alter database backup control file to, and you specify the location where the file has to be. It is going to be a binary file. You cannot VI, so be careful. Now the question which should be asked here in the seminar is, how often should I back up my control file? Every night? Every 1 hour? Once a month? Once a week? How do I know? Well, you should do once a night when you do your backups, for sure. When you do Armand backups, it will do it implicitly for you. You will see that in Armand class. But based on what I explained, what the contents of the control files are, we can derive from that information that whenever you add a new data file, whenever you add new log file, whenever you do some manipulation on the physical structure, you must immediately follow that operation by backing up your control file, especially in the environments where you have thousands of data files and it is 24/7 environment. It is very, very critical. So I just gave you one situation where you may want to do it, apart from weekly, nightly backups. The second command is alter database backup control file to trace. This will basically dump your control file in an English format, in English readable format, into a trace file. Where is the trace file going to be produced? In your user dump test directory, because this is where all your user trace files go. What is background dump test directory? Where all your alert files and your background processes are dumping their traces. So I will go to the trace file user dump directory and I will vi the file, and I will see that I have SQL text statements. What does it have? It has the location of all the log files and the data files. So now, why would I want to do this? As a DBA, there are three cases where you want to do it. If you remember in the DBA class where we talked about creating a database, if you remember the command, there's a create database command, and there are so many parameters there which says maximum log files, maximum data files, DB name. So as I said, when you create database, all these things will not change, they are fixed. The only way you can change those parameters is by either recreating the database, doing a full export import on the database, or by recreating the control file. I can say I can dump this that control file to a SQL statements into a text file, and you will see there are statements like maximum data files, maximum log files. I can change, then I can bump it up and run the statement, run the SQL script. It will recreate my control file. There are some changes you have to make depending on, do you want to reuse the control files or you want to create new control files. You can change the syntax, and you can say if you want to be in archive log mode or not. So this is one of the example where you will have to basically recreate your control file. Database data file operations. I was asked in one of the seminars, how do I change the size of my data file? Or another question was, hey, I'm creating a table space and I have one data file. Why should I keep adding more data files when my space is getting full? Why can't I resize my data file? Sure, you can. This is how you do it. There's no command. There is no command to say alter table space and resize my data file. The command to do is alter database data file, give the name and the location of the file, and then the resize followed by the size you need. Now be very careful. Imagine that as a DBA, you went to my seminar and I told you for better management you should keep your data file sizes to 3 gig, and when you create a table space and you create data files, you can have a smaller size initially. Let us say we create a data file of 1 MB, but you can extend that up to 3 gigs. So I put, okay, start with 1 MB, but keep growing automatically on your own. So I have done auto allocation, I have set auto extend on, but I'm saying stop at 3 GB limit. So now as a DBA, you go home and you say, okay, hey, it seems like all my 100 data files are beyond 3, 4, 5 gig. Let me squeeze it down. You run this command, alter database data file, the location excuse me, the location and the resize command. So what happens here? In this situation, you may fail on your operation. You may be able to squeeze the file down, or you may not be able to, depending on if there are any extents or blocks which are used and which are beyond the 3 gig limit. So let us say you have 5 gig data file and you had some tables there and they kept growing and growing, and they may have gone past the 3 GB limit which they want to impose by squeezing the data file back. You will not be able to do it because there are some blocks which are used, which are sitting between the area of 3 gig and 5 gig, right? So that is what I'm saying, that beware that you can only decrease the size of the data file with the space that is free between the highest used block of the data file and the last block of the file. If the table space is fragmented, the free spaces between extents cannot be deallocated this way anyways. So what we do, you check the DBA free spaces for details. You should run my DBA free space 933 space script I gave you, and we talked about in logical structures that we're going after the biggest chunk of free space. So in 5 gig data file, a single 5 gig data file, I may only have one 500 MB continuous free space. The total space which is free may be 4 gig, but they are all fragmented. I cannot squeeze and tell Oracle take all this free space, just like when we do in Windows. It will move all the used block in one side, and it'll move all the unused block in the other side, and then you can squeeze it. It doesn't work that way in Oracle. So if my largest available space is like 500 MB in this example out of 5 gig, the maximum I can claim back in one shot is 500 MB, assuming that free space is in the end. So what I can do is, in that case, I will say alter database data file name resize to 4.5 gig, not 3 gig. So I can claim some 500 MB back. So giving you some real life examples here. And the syntax for doing that is at the bottom, where we say alter database data file name resize. You can increase the size this way, you can decrease the size this way. Moving, renaming data files. Remember, we will be showing all these things live demo followed by this concepts. So how do we move and rename the file? Let us say you want to move the data file from location /u01 to /u02. How do we do it? We take the data file offline, we do operating system copy using cp command. So we physically copy file from old location to new location, and we must issue the following command. But before we do that, we should be running in archive log mode. In my test I will show you how it works. And what happened here? So by doing so, we are saying to Oracle that the file was in location A, now it is going to be in location B. So in the future there will not be any location A for the data file. And the command to do is alter database rename file old file location to new file location. In this example, I am basically renaming my data file from _1 to _111. Then you can bring the data file online and delete the old file from the operating system. Log file operations. What can you do on log file? Again, all these log file operations are also done using the alter database command. So what I can do, I can alter database, add a log file member to a group. As I said before, we have to have at least 2 groups, and each group should have at least 1 file. So basically I need to have 2 log files for Oracle to operate. Under normal condition, well, if one goes down, we will crash the database. So we normally don't just keep the minimum, we keep 3 to 5. I keep 5, and I keep a size of 250 to 500 MB per log file group. And within each group you may have 2 files. Okay, if each group has 2 files, all the other groups needs to have 2 files too. If the first group has 2 files and you have 5 groups, so each group should have same number of members. Okay, and the size of each member in a group should be same. I can have group 1 with 2 members, each of 500 MB. I can have group 2 with 2 members. I must have 2 members, but they can be of size 100 MB. And I can have other group 3, 4 and 5 with 500 MB each member. So to add a data file to a group, you issue the first command, alter database add log file member, the name, location, and you specify which group it belongs to. Okay, and the second command says alter database drop log file member. Here I am dropping the log file member, and you can say alter database drop log file group 4. That drops the whole group. And alter database add log file group 4. Here I am adding a new group called group 4, and I have 2 members with their locations, and after the brackets are over, I'm specifying the size. It shows me that each member is going to be 5 MB in size. One very critical comment about this for DBS to know is there's no way I can resize. No way I can resize up to 8i9i. I have to check in 10G that we can resize the size of your log file members. There's no command. What do you do? Let us say you went to a client situation where you are having the log switches which are happening so frequent that it is causing us log file sync waits and other log file issues, and you decided to increase the log file member sizes from 250 MB to 500 MB. How can you do it? You cannot. What do? You add and assume that they have 5 groups. You need to create 5 more groups, and with 2 more members in each group, and those members should be of 500 MB each. Then you make sure that you do alter system switch log file command. Alter system switch log file command will switch the log files for you on your command. So let us say the client had group 1 to 5, you added group 6 to 10, and you are right now writing to group 4, and I did switch alter system switch log file. It is switching from group 4 to 5 now. I will do one more time. It will go to log number 6 now. So log number 6 is where we have 500 MB, and now we are in good shape. Now what I will do, I will drop all the log groups from 1 to 5, and I am in good shape. So this is how I have to roll. I have to roll my logs and make sure the current log groups which I'm going to drop are not active, and if they're not active I can drop them. But I cannot, if you only have 3 groups and you drop group 3, you have 2. But if you have 2 groups, Oracle will not let you drop 2, because 2 are the minimum requirement for Oracle to operate. Archive log operations, I can say alter database, archive log, no archive log. I can say alter database, archive log, manual. All these commands, very important. Archive log operations are done on a mount stage. I have to say startup mount, not simple startup. If I'm running in a say no archive log mode, and I need to start my database in archive log mode, I need to shut down the database and start up mount and run this command alter database no archive log, archive log, and then do alter database open, and I will open my database and make sure that I will show you that in my demonstration more. How do we create table spaces? Finally, so much talk about table spaces, so much talk about extents and segments. How do I create my table space? This is it. Remember this, because I will be doing my test very fast when I do my tests. So let me spend some few minutes here. To drop a table space, we say drop table space name, including contents. Why do I have to specify including contents? Because table space may not be empty. There must be some lower level logical structures already there, like tables and indexes. So if I want to really make sure that I want to drop this table space, and I don't care about the contents, as a DBA I know what is there, which table, which index is there in which table space, and I know that I'm sure I really want to do this operation, I will say including contents. It will take care of all the indexes and tables which are there, and it will drop them as well. So how do you create a table space? We do is create table space name, and I say data file. This is how you create data files in a system. And we saw how do we create system table space data file? When we create database. All the other statements, all the other data files are getting into your database, are coming in your system by issuing this command, create table space name data file, and it is followed by the location of the file, the size of the file, which is 1 MB, and reuse. Again, as a DBA, never use reuse unless you are really sure. One bad command, you crash your database, you are screwed. So don't think this command even exists for you. Okay, and just to really make sure, we can always query dba_data_files and v.data file to see the file you are trying to reuse is it already active and attached to any other table space or not. Okay, so if you're really sure, then you can use it, but I, for junior DBs, never do it. And the very critical part now is the extent management local uniform size 8K. There are two different types of table spaces. One is dictionary managed, where all the management on the table spaces like allocating and deallocating space is controlled by the system table space, by the dictionary, by making recursive calls and all things of that nature. As we will see in the test, that the recursive calls go down when we go from dictionary managed table space to locally managed table space. So the dictionary managed table spaces are managed by a system table space, and there are a lot of recursive calls which goes through UTF, UET and FET dollar tables, and we are using system table space to store the information about my user defined table spaces. So there is a problem, right? Why? Let us assume again you have 1000 table spaces with 5 data files each, and there are 20,000 tables, and there are 1000 users inserting, updating, deleting data. You are allocating, deallocating extents, right? All that information has to be managed somewhere. Oracle need to know where every extent is for each table, right? That information is going to be in the data dictionary. Who has to manage that for you? Oracle kernel and system table space. So now you see there's a single point of contention and point of let us say point of contention for now. I'm lost of word here. So that is a single point of contention. Why? Because all this management is happening in a single table space. Okay, so Oracle became smart and say, hey, why are we stressing out the system table space? Why don't we do the same thing for each table space within each table space itself? Why should I manage your table space? Let every table space manage itself. And what it has to manage? The extent management, the space management, the free space, the used space, right? So to create a table space with the locally managed table space, it is called locally managed table space. You manage yourself locally within the table space yourself. Okay, so in order to create locally managed table space, we do this extension of the create table space by specifying extent management local. And if you look at the first command and the second command, extent management local uniform size and extent management local auto allocate, there I'm creating a table space type locally managed table space, but in the first clause I'm saying that let me decide on the extent sizes for all the objects which are going to be part of my table space, and I want the each size of the extent to be 8K. So even if I create a table or an index of a different size than what is specified on this table space, let us say I put 8K here because I'll be doing a specific test and I will prove the point. Internally it is going to convert into 16K. That is the minimum allocation required. But anyways, so let us say we go with this system and we have 1 MB. Every table and every object, and for argument's sake, let us say 8K for every table, every index which is going to be part of your this table space will have 8K initial next extents. We cannot change that. This is the only table space type where, and the next one too, when we are, so basically when we have locally managed table space, we cannot control the size of extents. Even if I say create table and give me initial extent, and I say storage and give me initial extent of 10 MB, 1 MB, it will not do it. It will give you 10 MB space, but it will convert internally extents of 8K sizes. Now very interesting design comes into picture. How an Oracle came with this new feature to remove the contention on one point, At the other point, we have a constraint that the objects which are part of this table space cannot have sizes which are different from what I have specified here. I said uniform size 8K. So now let us assume we have a table of 100 million rows, and I need, say, to allocate that table in this table space. What is going to happen? I need to allocate, let us say the total size of the 100 million rows is 1 GB. I need to divide 1 GB by 8K size. That number of extents I need to store my table in this table space. I may run out of my total number of extents possible in a system for a given object. That limit is imposed by the operating system and Oracle, and that is dependent on operating system. So if I am a smart DBA, what I have to do before I even create any table spaces and databases and objects and even your data files, what I need to do, I need to sit with my designers, sit with my business analyst, and get all the requirements. How much data you need to grow every month by month, day by day. How many people will be hitting my table space by table? How many people will be doing updates? How many people will be doing deletes in a given day? How many deletes? How many updates? How many inserts? I need to get a list of all the 20 things for every table, and then I will design and touch, even think of creating a single table. That is the true design which we do in the data warehouses and other custom databases, right? So what happened here? I may not be able to fit, based on the number of extents I need, my object in this table space. Even if I create a size of data file, say 10 terabyte, 1 terabyte, I don't care. But we may not run out of space on the data file, but we will run out of number of total extents allowed for a given object. So what do we do? As a DBA, since I know how the table is going to behave, what will be the total size of the extents, the total size of the table, I may have to create a different table space with larger uniform extent size. Instead of doing 8K, I may say, hey, because this table is big, let us say that each extent is 10 MB. So now you know what I'm getting at. So if there are a lot of small, let us say we have 10,000 tables. Out of 10,000, 5,000 are bigger tables. So I'll create a table space which is locally managed, which will hold the big objects, because my definition of table space will tell me that my extent size is, the uniform size is 10 MB. So I can at least not run out of space of total number of extents. Then I may have 5,000 tables which are kind of medium sized tables and which will not require more than 100 MB space. So I will say, give me a local uniform size of 1 MB and let it grow to 100 extents for each object type. And on the other side, I may have very small objects which is only taking like 20 bytes, 30 bytes, 100 bytes, kilobytes, So I will create something like uniform size of 16K. So based on the nature of my objects which are stored, the growth, the size, the activity, update, delete, inserts, I will be designing my table spaces. This is a very solid case study and it should answer all your questions. How many table spaces, what should be the size, based on design, based on objects. Cool. The next command basically talks about the same thing. It is locally managed table space, but I'm saying I don't care about specifying the size of extents. Hey Oracle, do it yourself. And what does do it yourself mean? I will demonstrate that in my test. So syntax is extent management local auto allocate. So the clause extent management local makes the table space locally managed. The last command is create table space name, data file, the location, the size, and since I'm not specifying extent management local, it is dictionary managed table space. Now one more case study I want to present is when you create objects inside a dictionary managed table space, you can specify the storage of your initial extent of a table and next extent and all these things, and that will take precedence over the default size on the data dictionary table space. On the locally managed table space size, it is other way around, and that is the only way it is other way around, where the higher level parameters of storage which are specified at the table space level are going to override the lower level parameters which are specifying at the object level. Very critical. Resize table space data files. So same thing, we already covered that. We do alter database, data file, file name, and the resize command. Add table space data files. So let us now talk about how do we add data files. The simple thing is to alter table space, because a data file has to go where? It has to be part of some table space. It cannot just sit dangling around. So what do I say? Alter table space, table space name, add data file, the name and the size. So this is how I add my sizes, to see what table spaces are there and what the file names are there, which data files are there in a table space, and what the sizes are of those data files which are part of your table spaces. You can run the following command: select table space name, file name, and I normally divide the bytes by 1024 1024, so I get megabyte sizes from DB8 data files. Auto extend table spaces, as we already discussed so many times. What I recommend is, hey, again, if I have a huge system, I'm single DBA, I don't want to be sitting every day 4 hours just managing my space by adding 100 bytes here, adding more data files. So what do? I will say, okay, let me create my table spaces data files, and I don't want to manage. I don't want to create 100 MB files and keep adding every other day 100 MB more and more. Let me put something called a max size and let it grow automatically. So what I say here is create table space name, and the data file name with the data file clause, and the file, the name, the size, and I say auto extend on. I am saying I don't want to manage my space too much. Why don't you just keep adding yourself more data, more free? Why don't you start resizing yourself internally and keep adding more space and not bother me? And I said there's a problem with that. And assume that we had one bad PL/SQL code and an infinite in loop, and in the infinite loop I'm doing insert, and it's inserting millions of rows. And I said, based on my command here, that my my table space data file size is 1 MB, and I'm saying the maximum size is 1 gig. It will not take much time to fill the 1 gig space, maybe a few minutes, half an hour. Burn bad code. If I don't put a maximum size here, and I said auto extend on, it will keep growing and growing and growing. It will keep extending the data file automatically all the way up to what point? Up to the point of taking away all the space from the operating system, and that is where you'll have a big issue and the system is going to hang. So be very careful doing auto extend. So what do we do? So don't go home and say, hey, because I said to put max size of 3 gig, that's what you should do, and you go home and say alter database data file, and you say all max size of all the files to be 3 gig. You may already have data files which are already crossed that limit. Let us say you have 100 files, and out of 100 files, 20 of them are below 3 gig. Yeah, go ahead, put the size of 3 gig, that's fine. What about all the other files which are already gone past 3 gig limit? What will happen then? This command will work, but it will not do any effect for you, because we already have grown past that point. And you will say, oh yeah, sure, I did auto extend on, I also put my 3 gig on, I should be fine. No, you will destroy yourself. Be careful. What will happen in this case? Let us say your files have grown to 5 gig. To go ahead and put a limit of 6 gig and monitor your free space. How much free is left? If it is 90% used, add another data file. So now there comes another point now. How much should we add when we create a new data file, or when we create new table space? What size should we start with? And if I'm adding a new data file to a table space, what size should I start with? Well, I do start with, in a big systems, 1 gig. Let it grow to 3 gig. Okay, you can start with 100 MB. So what logic can I deduce from this? What can I think of it? Well, look at your operating system, how much space is free. Do not just, when I say data file name size 1 MB or 1 gig, that space is gone from the operating system, and that space is empty for Oracle, but for operating system that space is gone. What does that mean? So be careful. If you are constrained on the space on the operating system, don't just keep adding randomly 1 gig empty files, right? So you may want to start with, because it might take 1 year for you based on your application and the objects to fill 1 gig space. So why you want to pre-allocate 1 gig for next 1 year right now? Why don't you allocate 100 MB? And so you have more space on the operating system, and 1 gig will be used in time next 1 year. So you have to make all the smart choices. And there are other commands like, we can change the status of the data files. We can say alter data table space name offline, bring it online, make it read write, make it read only. Online is same as read write. When you check at the status, if you run this command, call select table space name status from db at table spaces and give the table space name, and what you will see, you'll see status of online for read write, because when you do read write, you are online, you can do read and write operations. Hot backups. When you do hot backups, what happens? You are saying freeze my structures. Freeze my structures. Is it true? No. You cannot freeze anything. I'm saying hard backups. So while operations are going on, you're doing insert, update, deletes, you are copying your files over. So to enable, for Oracle, you have to tell Oracle that, hey, I'm going to run some command. After running the command, I will go to operating system and copy my file to my media like tape or some backup disk. And once my copy is done, I will tell Oracle and say, hey, I'm done. To issue that, this is how you do your hot backups in Oracle. You issue a command called alter table space name and begin backup. Then you physically copy the file from the operating system which are belonging to the table space, and when the copy is finished, you say alter data table space name and backup. So any question why this command can fail? We will see in the demo. You must have the database running in archive log mode. Undo table spaces, as I said, they came in 9i, and we create an undo table space and give it a name and the file size and the location, and I can use all the commands which are part of your normal table space like auto extend and max size and all these things, and I give this table space to your Oracle kernel, and this undo underscore table space parameter is there in your init.ora file, and you will say that parameter value is tspundu. So Oracle, when it starts, it knows it has to use this undo table space for self-managing your rollback segments. Oracle tries to keep for every transaction, it will try to simulate and try to create dynamically one rollback segment internally, and that segment will be part of this table space. It has a lot of performance benefits, but it also, you have to be careful. You may have if you have auto extend on, or you may basically extend your table space to a certain point which may not be the desired feature, right? So you don't know. What I'm saying is, you may use this new feature, but you can also use the old feature, like creating manually all the rollback segments depending on the application. Every new feature has some problems, so let me stop at that. But this is how you create table spaces for undo table space types. Temporary table space, very important again. As I said, temporary table space is a table space which is used for managing your temporary segments, and the temporary segments are used for intermediate operations which are let us say part of your group by, and you're doing a summation and average, Oracle has to temporarily sort and merge the data in some place, right? So it will use this temporary table space, do the operations, give you the results back, and you're all set to go. Now let us say that now the temporary table spaces are not normal spaces, they are not locally managed kind of table spaces which we saw before, or they're not kind of dictionary managed table spaces. Okay, they are temporary type. So that's why the syntax to create is create temporary table space, not simple create table space. Give the name, and it's not data file, it's called temp file. So that is a syntax difference, and you give the location of the file, the size, and then you reuse or not, and auto extend on and off or not. And then I'm here saying, hey, extend management local, and and the uniform size of 1 MB. Okay, so let us say you want to add a new data file which is temporary table space. You can add that, and then you can say alter user and default temporary table space and give the new table space name. This is how you allocate your table spaces to users. But if I want to say drop old temporary file, and the temp file is a system default temp file, and there's only one of them, Oracle will not let you drop it. So what you do is you create a new file. I said here Sara temp, okay, and I say alter database and add that new temp file as part of my default temporary table space in the data file. Then I can go and drop my original temporary table space. So again, it is a temporary table space. You can do all the operations on that. You can say alter database temp file and the file location and drop it. You can add more temp file. You can add, you can resize them, make it online, offline, and do all these operations. But specifying this create temporary clause is going to tell Oracle that this is a temporary table space, and use your newly optimized features and internal structures to use this temporary table space in a more efficient and optimized way. If I had created a dictionary managed table spaces, Oracle will again use the system table space to manage that, and you may end up, think about 1,000 users again, and they all doing their sorting and merging. How many temporary segments you may need in 1 minute? Thousands. And you're using the system table space to manage that. That may not be desired feature. Oracle came with more efficient way of doing it. This temporary table space is used for advanced feature like global temporary tables as well. We will talk about that later. So the thing to remember is, if you only have one table space which is temporary table space, and that is also part of your default table space in your database, you cannot drop it. You have to create another one, add that part of your default table space in the database level, and then use a dynamic SQL script to change the temporary table space for all the users to this new table space, and then you can drop the old temporary table space. And this is what I am describing here. So I create temp2, okay, and I say alter database default temporary table space temp2. So I have to temporarily move to a new location. Then I can drop the original one and recreate it if you want to, because the whole operation I was trying to do was I want to resize my the original temp table space. I cannot do it properly. I cannot drop it. I cannot do many operations on it. I will temporarily create new table space, move my alter database default temporary table space there, and then drop the original one and then recreate it, because I want to still maintain. Now why I did that? Why do you should ask me, hey, why did you do it? Why don't you just create new table space and then drop the old one? Well, imagine that 1,000 users, 10,000 users, they all have default temporary table space called temp, not temp2. Either I go and change everybody, right, or I do this temporary operation and then I rebuild my temp table space. If people are using it, you cannot destroy it, so you have to be careful when you do this operation. And there are 10G specific operations which you can do. here on the undo table space, where you can specify the retention, no guarantee, and guarantees, and things of that nature. And you can have this create temporary table space belonging to a table space group. We will talk about it in the advanced features. That concludes the table space command seminar.